Good evening, everyone. Today we'll discuss about matrix multiplication using C language. So, in general mathematics, to multiply mathematics, we should know about the number of rows and columns of a matrix. So, let us consider according to this example. So, it is a matrix one, M1 across N1 matrix. Here M1 is the number of rows and N1 is the number of columns. Second matrix dimension is M2 across N2. Now, with respect to the mathematics rule, here n1 nothing but number of rows in a first matrix be equal to uh, number of rows in number of columns in a first matrix number it should be equal to the number of rows in uh, second matrix. So this is the rule we should follow to multiply. So column nothing but here how many columns are there? Three columns are there. Now three columns are there. The three columns are equals to the same number of rows we required in the second matrix. So how many rows are there? One, two, three. So now both are three. Now we can able to multiply. Otherwise we cannot multiply. So let us practice the one this example according to the mathematics. Accordingly, we'll apply the rule for the programming writing. So first, how we are multiplying. So in every matrix, to process in a programming, we are generally considering the two variables. We are practicing several times with I and J variables. Let us do the same thing for this corresponding program. So the row value is represented by I, column value is represented by J. So this is one analysis. Will it suitable for this example or not, or for multiplication or not? So now, what is the row number? Row number is a 0. So I could say it is a I is equals to 0. Now, according to that one, first I have selected a first row of first matrix. So the first row of first matrix will be select, and it should be multiplied with first column of the matrix. So these two should be select. After multiplying these two, then we should go to the second column. We should go to the second column of a second matrix. If there is a third column should be multiplied. If there is a fourth column should be multiplied. We have to get a single row from the first matrix that should be multiplied with all columns of a second matrix. So that is the flow we should follow. Now first, what is the resultant dimension? Matrix will become resultant dimension. So resultant dimension matrix will become M1 into N2. So these here we should remember the one condition. N1, the number of columns of a first matrix must be equal to the number of rows in a second column. Resultant matrix dimension will become M1. So the resultant dimension will become, you will get a one result. So this is the resultant matrix dimension is equal to M1 into. So that will become M1 cross N2 dimension result it will produce. So this is a general multiplication rule. Now let us take, I have selected a first row. So now that will be multiplied with the first column. And the multiplication also element to element. 2 into 5 plus 4 into 8 plus 5 into 4 like that. So first row selected, three elements are selected, second first column of the first matrix selected, second matrix selected, element to element, they should be multiplied. So here I want to multiply this instead of, so just I am removing this, just multiply. So first, what is the first row? First element 2. So 2 should be multiplied with of element of a first column plus after multiplying second element of the row, and it should be multiplied with second element of a first column. That should be again placed with third element of a column. So this is the way we are multiplying. This entirely one result you will get. So this is one element in the resultant matrix. This is one element in the resultant matrix. Now the multiplication of a first row with first column completed. First column completed. After completing this is the one element result, which become a which transfer the same multiplication with second column of a second matrix. Now we are selecting the second column. Now here what happened? First row of a first matrix still multiplying with the second column of a second matrix until it completes the all columns of a second matrix. If there are only two columns, I have taken in this example. In case there are three columns are there, three multiply type. Four columns are there, four time multiply. So like that. Now what happened here? First row of a first matrix Row cannot be changed until you complete the all columns in the first matrix, second matrix. Until you complete the all columns of a second matrix, the row selected first matrix cannot be changed. So 2 into 3. Plus again 4 into 7. Plus now 5 into 10. This is become a second element of the resultant matrix. So likewise, now I could write here. Now this is the resultant matrix dimension. How many columns are identified? Two columns are identified. Like that again. So after completing these two columns, next, the next row will be transplant. Second row will be selected from the first matrix. Now first row multiplied with all columns. So the turn switch to the second column. Turn switch to the second column. Again, second column also will multiply the all second row. Turn switch to the second row. This second row of the first matrix again multiply with the all columns of a second matrix. Second row of the first matrix. Multiply with all columns of a again second matrix. Then next one, what happens? Again, after completing that, same transfer to the third column of a first matrix. Again, we shall also multiply the all columns of a second matrix. Like the process is going on. Okay. So now let's analyze with variables now. Let's analyze with variable how the transferring of row to rows, and every time selecting of row, how the control transfer to the column to column. So that analysis we had to do with some variables in the for loop. Basically, we had to use the loops for to process the arrays. Now here I am selecting one variable. Every time we are practicing with I comma j. Let's see how it is going to be happen with I comma j. Just I want to remove all the part. Want to remove all the part. Let's analyze with I and j. When I is equal to 0, what happened here? When I is equal to 0 element, here we have I is equal to 0 element. So this is basically 0th number element. Column wise, they also will become 0. Column wise, they also will become 0. So that is the first element. I want to take a 16 5. Okay. Now next, according to that, here what is this? It is I is equal to 0. But according to the column wise, so this value is become a 1. Okay. Now, first, for every time I is representing 0, so I always 0 for 0. But column value will be same. So the column value is become, here it is become 2. 0, 1, 2. So now whenever you are selecting 2, 4, 5, the I and J values are in such a way that I value always will become 0 itself, but J value will be changing from 1 comma to 0 comma 0 comma 1 comma 2. So like that values are being changing for J. Similarly, we are selecting the column of the first column. We are also selecting the column. This column we are selecting. Now, what are the values according to the I comma j? Let us consider this one also representing with I comma j. For my addition process, we have taken in only two variables, I comma j. Okay. So similarly, here also we are taking I and j. So when what is the five value? I is equal to 0, and here again j also will become 0. Okay, fine. For this one, I is equal to 0, j is equal to 0. For this one, I value is become 1 because it is a second row, and j value is still 0. Still 0. So what is the third element? The third element I value is become 2, but j value is become 3 0. The difference how the elements are selecting. How the elements are selecting with respect to I and j. Now, whenever you are selecting a column, in this process, I values become changing from 0 to 0 comma 1 comma 2. Whereas coming to the j value, it is become 0. No, we cannot apply I comma j common for two matrices. We cannot apply. Why? Because whenever you are selecting first row, The first row nothing but 2, 4, 5. So these are row. In this row, what happened? I value 0, 0, 0, 0. J value been changed from 0, 1, 2. When I've committed this column, I values become 0, 1, 2, but J values become 0, 0, 0. We cannot commonly apply the I comma J for two matrices. It is not possible. So we have to change the variables to manage the row selection and column selection from the second matrices. So they are selecting one for row from first matrix, column from second matrix. So we cannot manage with same variable for two matrices, I comma j. So now, but we remember, we should do process. We should remember one process. Here I is become constant for 0, but j is become changing from 0, 1, 2. In this case, I is become 0, 1, 2, j is become 0 only. So now let us take a variable. So that variable name as a k. Let us take as a k is a common variable. Obviously, I is not being changing. So let us keep as I is equals to 0. But for second variable, here you should take a k. So what is the k values become 0, comma 1, comma 2. Here also, here in this matrix also, let us take j is a common. Okay, j is a common. J is just 0. But I values become changing from 0, comma 1, comma 2. In these two selections, a variable is commonly selecting the values or incrementing the values 0, 1, 2 in first matrix and second matrix also. For that changing of values, let us take k value. Now, in place of I here, I am taking k. It is also changing from 0, comma 1, comma 2. Here also have taken in place of this 0, in place of they have taken k. It is also become 0, comma 1, comma 2. Now, here we start using a third variable k. That is becoming common for the two matrices, and I comma j are different for different matrices. So based on this, we have input one third variable k value. Every selection k value been changing commonly um, uh, increment the value from 0, 1, 2 from first matrix, second matrix. So that we have taken a k value third variable. Now the first matrix uh, variables are I comma k. Second matrix variables are become k comma j. In this two matrices, a common value will be changed with a common increment, that is 0, 1, 2. Here also 0, 1, 2. And we are also expecting, let us consider I representing the row is represented by the I, then column represented by a k for first matrix. Now here what happened here, k is representing for row and representing for column. So now we are also expecting the number of columns in this first matrix will be equal to the number of rows in the second matrix. Yes. It is also become k is equal to k. I could write here that k is equals to k. K is equals to k. Both are now k, only k. This is also one kind of analysis mapping to understand the multiplication. So this is a common variable k. It is the same value in the first matrix and the same value will be in the second matrix. So here it is representing the number of columns. Here it is representing the number of rows. Now number of columns and number of rows must be equal. So k is equal to k. Now it is become 3 is equal to 3. So like that we can accommodate with the one another variable k. It is common for two matrices. Now we can able to process the multiplication. So let us is this process will be work out or not? Now we are multiplying. Now we are multiplying 2, 4, 5. Now 2 into for first row and first column of first variable. Now this is a multiplication of when I is equals to 0. In this multiplication, what happened? I is equals to 0, j is equals to 0 element of first row, and first column of second matrix, that is become again I is equal to 0, and here it should be a k value. I should consider it as a k value. It is k. Now here also k is become 0. So forget about all this. They been changed now. They are not I comma j. They are not I comma j. We been changed to I comma k and k to j. So they are not. Okay. So we are representing them with I is equals to 0 and k is equal to 0 scenario. K is equal to 0. Now what is this? I is equal to 0 and k is become 1. K is become 1. What is the third one? I is equals to 0 and k is equals to 2, like that. K is equals to 2. Here what happened? Here what is this? I is equals to 0. Sorry, k is equals to 0 and j also will be, j is become 0. Next one, k is equals to 1, j is equals to 0. What is the next one? K is equals to 2, k is equals to 2, j is equals to 0. So these are the elements we are multiplying. Now this is place width and this is place width. Next element multiplication. What is the next element? 4 to 8. Now we want to multiply 4 into 8. But what is the 4 value? What is the 4 index? I is equals to 0. At 4, I is equals to 0. What is the k value? K value is 1. Okay. Now what is the 8 value? 8 k is equals to 1. And accordingly, j is equals to 0. Become different. And the last value multiplying. Third element of a first row. What is the third element? 5. It is multiplying with last value column. Now what is the 5 value? I is equal to still 0 because it is first row only, but k become 2. Here what happened? K is equal to, it is third row in the second matrix. So k is equal to 2 and k is equal to 0. Whenever we are multiplying with first row and first column of two matrices, here what happened? I value cannot change, I is equal to 0. J value also cannot be changed. But whereas coming to the, sorry, here it should be, value, okay, what happened to k, what happened to k value? Initially it is k is equal to 0 into matrices. In first matrix k value 0, in second matrix k value 0. In second first matrix k is equal to 1 and second matrix k is equal to 1. Third value, third time, whenever multiplying with the third value, k is equal to 2 and third value of a column also k is equal to 2. So k is incrementing commonly for two matrices 0 0 1 1 2 2. So like that you will understand more when we are multiplying with the first row with the second column. If you are multiplying with the first row with the second column, you will get a clarity how the values are being changing. I comma j comma k values. So based on this scenario, we have to write the code. The code line is very small. If you understand this logic, the code lines are will become very small. Now, what is the second first value? Again, we are multiplying with 2. And what is the second column first value? 3. Now we want to multiply with 3. Now, what is the index value of 2? 2 index value is equals to I is equals to 0. Again, k also equal to 0. But whereas coming to the 3, where 3, j is equals to, no, but the first should be k is equals to 1 column. K should be, sorry, k again 0, 0, but j is equal to become 1. Okay, similarly, this again place with next multiplication. 4 into 7. 4 into 7. Now what is the 4 value? What is the 4 index value? I is equal to 0 and k is equal to will become 1. What is the 7 index value? 7 index value will become k is equal to 1 and j is equal to 1 because it is the first column. So that in first column, whenever you are selecting, all the j is become 1. And next, what is the third value? 5 into 10 we are multiplying. 10 we are multiplying. According to that, what is the I value? I value it is 0 for first one. What is the k value for this? K value is become 2. Now what is the j value? What is the k value here? Here it is k value is become 2. K value is become 1. See, whenever you are multiplying with first row with second column, here also here k is become 0 in two matrices, and here it is k is become 1, commonly incrementing for two matrices. So now k, a third variable we have taken is a value which is incrementing commonly for two matrices. So I am always calculating for first value two columns of a second matrix. Likewise, we have a 10 row two column multiplication, third row two column multiplication. So like that we have a total six values we are identifying in the resultant matrix. The resultant matrix dimension is become, what is the resultant dimension? M into n, m1 into n2. So I could say I into j. So whenever k is equal to k, n1 is equal to m2, then it is become k is equal to k. What is the resultant matrix? Resultant matrix dimension is become m1 into n2. It become a resultant matrix dimension. So what is the m1 value? Total number of rows. Okay, three rows. Okay. So three rows we find n2. Total number of columns in a second matrix. Three rows and two columns. So resultant matrix we can identify. But we can able to compare with the I value into, so I into j. So in this dimension, you will get a resultant matrix. You will get a resultant matrix. Okay. Let us write according to the code now. For every selection now, I'm just providing the main major code of the multiplication. So for every selection of row, first row of a first matrix, first row of a first matrix, how we are representing with the first row of first matrix? Using I value. I value. Okay. So what is the row representation for second matrix? K. What is the column representation for the first matrix? K. And what is the column representation for the second matrix? J. So that we have to remember. Now for every selection of row, so row of selection from 0th row onwards. First row is become a 0, second row is become a 1, third row is become a 2. So obviously that I should be less than M1. M1 because there are three rows are there, 0, 1, 2. That is a condition. And every time we are incrementing the row value. Usually we are taking 0th number row, second time we take the 1 number row, next 2 number. So this is a row. We have selected a row value from the first matrix. After selecting the first matrix, what we should do? We also focus on column. From first column, I want to select from the second matrix. Still, I don't apply the k rule because k is a common variable for the two matrices. So now we didn't practice the k. Let us select the j value. Here also we need to select the column from the second matrix. That is also starting from j. So 0 and 1, 0 number column, 1 number column, 2 number column, 3 number column. So in this example, we have two columns, so that it is a 0 number column, 1 number column. So total number of columns are n2 number of columns are there. N2 number of columns, so that j is equal to j less than n2. Because we are counting 0, 1. Total number of columns have become 2. So less than 2. And again, it's a plus. Enter. Now, we should process the next index of first row. So that is always it is a common variable from matrices, that is a k. For every section of first row or of a first matrix, k value should be starting from 0 to where it should be moved. K values become 0, 1, 2. Nothing but it is a number of columns. So it is become an n1 number of columns. The same k value also is for the rows. 0, 1, 2 of the second matrix. That is become a M2. Now you can select the condition for every selection of K. We move up to N1 or else. So that I am writing here, that is your wish. Or else we can take, I'm writing here, or you can take condition K less than M2. M2. Any one of the condition you can use because both are will be same. We already tell that N1 could be M2. So any one of the condition you can use either less than N1 or M2. If both are equal, then only we can able to multiply. Otherwise, we cannot multiply. So that condition we should write in the program also. So K plus plus, K plus plus. Now here actually the code we should write. These are only the selection of index values. Now for every selection of I comma j comma k values, what we should do? For every selection of I comma j comma, so we know that from the matrix here, we are selecting I, the number of rows are k. We are multiplying with B matrix, where initial index rows are k and column number value j. These two are multiplying. Every multiplication is again adding with next multiplication number. First value to first value, second value to second value, third value to third value. We are multiplying and we are summing all the results. We are summing all the results so that we should store at the resultant matrix index. Resultant matrix dimension is how much? I and j. Already we discussed here. When k is equal to k, that is n1 is equal to n2, the resultant matrix will become a m1 into n2. M1 nothing but I, M1 nothing but I, N2 nothing but J. So now this is becoming resultant matrix dimension, I into J. So that is become considered like a some C matrix. But every time the element should be add with the first multiplication value. Every time multiply and add. It seems like it. It seems like it. Generally we had a practice C language. Sum is equal to sum plus I. So kind of sum of natural numbers for this program we have done this. In such a way, we are adding every multiplication value to next multiplier value. Finally, you will find out a result of a particular element like that. Multiply and add, multiply and add, multiply and add. Here see, multiply 2 into 3, add with 4 into 7, add with 5 into 8, 5 into 10. Total value is become that element. In such a way, we are multiplying and we are storing it I comma j element of a resultant matrix. Now let us discuss with uh, clear analysis. Even though we cannot understand how the multiplication is going on in the real time, if you understand the multiplication program in C language, not for a matrix multiplication, you can understand complete two-dimensional matrices or whatever the logic they are given. When let us see the number of cases. When I is equal to 0, what happens? When I is equal to 0, the control will verify the condition. If I is equal to 0, is that I less than M1? Yes, obviously M1 less than M1. According to our example, it is less than 3. So then it is entered into the inner circle. What is the inner circle J value? So inner circle. J value is become initially 0. It is also initially 0. So J less than N2. Again enter into the next inner circle. Here we have a K value. So now here we have a K value. What is the initial value of K? 0. 0. As it is condition true. Control enter into the block of the code. Okay. So now these are I just want to represent with a bar outer for loop. This is a second level for loop. So this is a third level for loop. So like that let us represent. Okay. Here what happened here? K is equal to initially 0. When K is equal to 0, the multiplication will done with A of I is equal to 0. So I could write here I is equal to 0. K is equal to how much? 0. And multiply with B of what is the K value? K value 0 only. 0. 0. What is the J value? Also 0. Now these values will be multiplied and store the result at is equal to C of 0. I is equals to 0. Again J is equals to 0. It is been adding, still adding. It's not completed. It's been adding the results. So I don't no need to represent this. Dynamically, our values are getting added. Now next, whenever k is equals to become 1, k again increment. Obviously, k will after increment, k will be increment and condition will be defined. After this condition, to control again enter into the block of the code. So now we can write when k is equals to 1, then the multiplication is become k is equal to 1. A of 0, 0 through itself, I is equal to 0, so we are 0 through. But second column is selected. Right? Second column, because that is the second element of first row. Second element of first row multiply with second element of what is the b value? Okay, b of k. K nothing but here it is the k. K is k already become 1. 1 nothing but it is select the second element of first column. When k is equal to 1, second element of first row. Okay. So now what is the j value? J value 0. Because j here it is 0. I also 0. What is 5? These are the values will be multiplied. Again, when k is become again incremented to 2. Now then one multiplication value will become, yeah, still we are at I is equal to 0 only, but k value is become 2. It is multiplying with nothing but is a third element of a first row. Multiplying with, uh, again k is become 2. Here it is become 0, third element of first column. These two are multiplied. Third element of first row multiply with third element of first column of second matrix. These two will be multiplied. Whole sum will be saved in a I comma j element position of a C. Because I comma j comma 0 0. So 0 element position will become sum of all these multiplications. Okay. When k is equal to will become 2, it become 3, the condition will become false. In this case, condition will become false. Now continue. We'll exit from the inner for loop. And again, we'll go to the incrementing of exit. Here it is exit because whenever condition false, obviously exit from this for loop. But it is already inside the one more for loop, so control transfer to the j plus plus. Now here what happened? J will be increment. Second the for loop, j value will be get update. It become 1. Still I is equal to 0 itself because we didn't reach to the I until j condition false, we cannot reach to the I. Okay. So j is equal to will become 1. Again control transfer to the inner for loop of j. What is that? Again it is k. Now when j is equal to when j is equals to 1, again k is starting with a 0 onwards. Again k is starting with 0 onwards. Then what is the matrix to become? There is no change of I value, I0 itself, because that is first column, first row, first matrix. But now we want to multiply with second column of second matrix because j will become 1. That represents the second column. So 0 itself. That again multiply with this time B column being changed. Row value k, but column value always will become 1. Second column selected. Okay. Now when k is equals to 1, again what happened here? So second element of second column. A of 0, second element of first row. That k will become 1. Now the second column, second element is selected. And again k is equals to uh, 2. Here what happened? In this way, multiplication is going to be done. A of 0 to multiply with P of 2 and 1. And where they will use this from I comma j index. What is the I value 0? Now they can store C of I value 0 only, but j value will become 1. In this index position, the result will be stored. Here the where is the result will be stored in the which element position? 0, I0, J0, index position, result will be stored. Like that, multiplication will be done in the real time in C by using C program. So the major core part only I have explained. So entering the value into array and verify these corresponding condition, number of columns in first matrix, rows in second matrix condition verification all should be done before this code. So in the next video, I will explain with new concept.